Hello all, welcome to this new series about machine learning. In the first video, we'll see introduction to machine learning. Let's start. So in traditional software, we write rule-based algorithms. For example, let's suppose we have a software which tells whether the patient has high fever or not. So you input the temperature value. If it is more than 100, it will say high fever, otherwise it will say no fever. So it knows only what we have coded. For example, if you input a value like 30 or maybe some unknown value, it will fail and it cannot tell more than that. That's rule based software. Now suppose we have very unknown data and we don't know much about the data, like unstructured data, and then we want to detect something, then it's very difficult to write a traditional algorithm, and that's where we write machine learning algorithm. So suppose we have a image detection algorithm. So you have hundreds of different images of different animal, and from the image you have to detect which animal is there. So now it's very difficult to code for such software because there is no fixed rule that if you find this in this image then it's a dog. It's very difficult to write such rules. But in machine learning, what it will do is it will have the training data. It will learn the patterns from the dog image, from the cat image, from the tiger image, etc. And then based on these learnings, if you give it a new image, it can tell whether it resembles a dog, cat, or tiger, and that's where we use machine learning. So you have data, you learn the patterns from data and then give an output. So it's not a rule based, it's pattern based. At the core of it, it applies different mathematical models, and there that is where the different types of machine learning models are. So every model is using some different mathematical concept, and then in the end it gives some prediction. Yeah, so in a basic machine learning model pipeline, you collect the data, then generally 80% data is a training data, or sometimes 90%, and then 10% or 20% you keep it as a test data. So you train the model on the training data and then you evaluate the model on the testing data. Now there are three high level categories of the machine learning model: continuous, classification, and neural network. In continuous machine learning model, you predict some particular value. Suppose you have a housing prediction, housing prices prediction model. So 2010 the price was 100, 2020 the price was 200, 2030 the price was 300. Suppose this is your training data, and then you want to predict what will be the price in 2040. The output will be something like 400, 500. So this type of model where there is a continuous value and you predict that value are called as a continuous model. Classification model, there is no fixed continuous value as output, but it tells the class. So suppose again image classification example, you have like random animal images, and some are dog, some are cats, some are tigers. So you train the model first on the available images with the labels: image 1 cat, image 2 tiger, image 3 dog, etc. And in after the training is done, you give it a new image which was not part of the training data, and then it can predict whether it's a dog, cat, or tiger. So these are three classes in which it is predicting. That's why it's called as a classification model. And if it predicts in only two classes, it's called binary classification. More than two classes, it's called multiple classification. Then the last category is neural networks. This is very similar to the traditional machine learning model. So you get the data, there is a training, and then there is a evaluation phase or the output phase. But the difference is the architecture. In neural network, generally the architecture is a layered architecture. So you take the training data, and these layers are then divided into three main categories: input layer, hidden layer, and output layer. So the training data first goes to the input layer, then there are hidden layer, which are basically a stack algebraic operations, and then there is an output layer which tells the output prediction. So let's take again an example of image classification. So you have so many different type of images. Some belongs to cat, some belongs to tiger, some belongs to dog. Then it goes to the input layer with labels for every image, what the image is for, and the first layer might see how many ages are there. So it will record some pattern. Okay, there was one age found at pixel 00 with weight as 0.35. Weight is basically some kind of mathematical representation for that age. Like if the age is thick, it might have more value. If it's thin, it will have low value. So a particular pattern in the image and its mathematical value. Then the second layer might see another patterns like colors in the images or brightness in the image and its mathematical value. So there are different types of layer which studies different types of patterns and its weight, and in the end we, for every image, layer 1 learning, layer 2 learning, layer 3, all this gets averaged out into the final outcome layer. And it will say, okay, if this pattern A learned in the layer 1, pattern 2 learned in the layer 3 are having value from 1 to 10, something like that, or range X to Y, then that's a dog. Range Z to A to B, that's a tiger. Range E to F, then that's a dog. Something like that. So there is a lot of depth inside this model. That's why they are also called as a deep learning model. The initial inspiration for such models was based on the human neurons. That's why they are called as a neural network. But with the time, they have evolved into a complete different mathematical concept which do not mimic the human brain activity anymore. But the initial inspiration was that. That's why they are called as neural network, and there is a lot of depth. That's why they are also called as a deep learning model. So that's it for this video. In the next video, what we are going to see is different type of metrics that we can use to evaluate a machine learning model. Thank you.